Again, welcome to statistics. This is our DSRT 734 class. In these lectures, we will go through hypothesis testing for the mean using large samples. When we say large samples, it means a samples that is greater than or equal to 30. So our main objective here is how we're going to learn how to find the p-values and also using using them to test a mean, population mean. Also use the p-value for a z-test, find the critical values, and also rejection regions in a normal distribution. We should also learn how to use the rejection regions for a z-test. So first, we start with using the p-values to make a decision. We say the decision rule based on the p-value. Now, to use the p-value to make a conclusion in hypothesis testing, we always compare the p-value with the alpha. The alpha is the level of significance. So if the level of significance, let's say, is 0.05, it means if the p-value is less than or equal to 0.05, then we are going to reject HO. If the p-value is greater than 0.05, then we are going to accept HO or fail to reject HO. So again, to use a p-value to make a conclusion in a hypothesis testing, we always compare the p-value with the alpha. So now we say that if p-value is less than or equal to alpha, then reject HO. If p-value is greater than alpha, then we are going to accept HO, or we're going to fail to reject HO. So let's see an example here. Here they say the p-value for hypothesis test is 0.0237. What is your decision if the level of significance is 0.05? So here we can say that 0.0237 is less than 0.05. So we are going to reject HO since P is less than alpha. We are going to reject HO. So the solution here said because 0.0237 is less than 0.05, you should reject the null hypothesis, which is reject the HO. Now, second, we have the level of significance to be 0.01. So if it's 0.01, it's okay. 0.01 is, let's do it. Because 0.01 is less, or we say 0.0237 is greater than 0.01, we are going to fail to reject HO, which means our p-value is greater than the alpha value. So we can see the difference of these two examples. The p-value is the same, 0.0237. But here, the alpha value, or the level of significance, is 0.05, which is greater than 0.0237. So we're going to reject null hypothesis. But in the second question, 0.01 is less than the p-value. So in this case, we are going to accept HO. So this means the p-value is greater than, again, the level of significance, which is the alpha value. So finding the p-value, here we said after determining the hypothesis test, standard test statistics, and then the test statistics corresponding area, do one of the following to find the p-value. Now we have three ways of finding the p-value. First will be our left tail test. If it's a left tail test, the p-value will be the value that we get from the standard normal table. Again, in these lectures, we are talking about hypothesis testing when the sample size is greater than 30 or equal to 30. And also we know the population mean, we know the population standard deviation. We can also find the standard mean because sample mean, the reason because we have to use the sample. So if that's the case, it means we can do our test statistics using the z-value or the z-score, which means to find the p-value, if I know the z, I have to use the standard normal table. So for right tail test, we find the p-value will be the area in the right tail. And for a two-way test, it will be 2 times the area in the tail of the test statistics. Again, we will see a diagram, so we may again get the concept. So let's see this example and we will see a diagram. So find the p-value for a left tail hypothesis testing with a test statistic. So, excuse me, so here the z is given to us. The z-value is negative 2.23. So since the z-value is negative 2.23, I know the test will be left tail because 0 is the middle. So to the negative side is the left, to the positive side will be right of 0. So now we need to decide whether to reject HO if the level of significance is alpha 0.01. So first we draw our diagram, normal distribution. The z-value is negative 2.23 and it's a left tail. So this is the blue region. That's what we are looking for. So we go straight to the standard normal table. And when we look for the value negative 2.23 for z, the corresponding p-value will be 0.0129. Now, let's go back to the alpha. The alpha is 0.01. So this means the p-value is greater than the alpha value or the level of significance. So we need to reject HO. So here we say, because 0.0129 is greater than 0.01, you should fail to reject HO. Oh, sorry, we will fail to reject HO because again, the p-value is greater than alpha. We always say that if the p-value is less than or equal to alpha, then we are going to reject HO. But if the p-value is greater than alpha, then we're going to accept HO, fail to reject HO. So let's see the second example. Now they say we should find a p-value for a two-tailed hypothesis test with a test statistics of z equal to 2.14. Decide whether to reject HO if the level of significance is 0.05. Now we can see here, first is two-tailed, and secondly, the z-value is positive. So it will be two-tailed, but we are going to find our original p-value in the right tail. So let's draw the diagram first. So when we draw the diagram, always 0, the middle, z is 2.14, so to the right. So I'll go to the standard normal table and I'm going to look for the value. So when we look at the p-value in the standard normal table, as we said earlier in our previous lecture, always the value is from left to the z-value. So we get 0.9838, but we are looking for the right tail because z is positive. So we subtract from 1. So our original p-value will be 0.0162. Then we multiply by 2 because we are doing two-tail. The answer we got was 0.0324. Now, since 0.0324, which is p, is less than alpha, we are going to reject HO. So here we say since 0.0324 is less than 0.05, we're going to reject HO. So we move to the z-test for population mean. Here we say this can be used when population is normal. That's a normal distribution. Also, we know the standard deviation. And most important, the sample size should be at least 30. Then we can do our z-test. So z statistic test, always we have to know. The reason why we have to know the population mean also, and also this is used for only normal distribution. is because the Z value will be the sample mean minus population mean over standard error. The standard error is the population standard deviation divided by square root of sample size. So here we say the test statistics is the sample mean. So we need the sample mean. And the standardized test statistics is Z. We give me sample mean minus population mean divided by population standard deviation divided by square root of sample size. Now, population standard deviation divided by square root of sample size is the same as what we call the standard error. And also standard error means the sample standard deviation. So here we say when n is greater than or equal to 30, then the sample standard deviation S can be substituted for the population. Now, using p-value for a z-test for the mean, population mean, again, this is the steps. So first we need to state at the cream, and we state the cream mathematically. Stating the cream mathematically means we are going to state our HO and HA. So we need to identify the null and also the alternative hypothesis. So we state HO and HA. HO is our null hypothesis, HA is our alternative hypothesis. Then we need to identify the level of significance. So we need to specify the level of significance, which is the alpha. Then we also need to determine the standardized test statistics, which is the Z value or the Z test. It will be, again, the sample mean minus population mean over population standard deviation divided by square root of the sample size. Then after that, we go to now we are doing the Z test. So we use the standard normal table, So after that, we look for the p-value in the standard normal table based on the Z value given to us. Then we get a p-value. Now there are three ways. If it's a left tail, the p-value is what we get from the table. Now, if it's a right tail, when you get the p-value from the table, you subtract it from 1. Now, if it's a two-tail, when you get the p-value, you multiply by 2. Then next, based on the p-value, we have to make our decision now. Only 2 decisions here. If the p-value is less than or equal to alpha, which is the level of significance, then we are going to reject HO. If the p-value is greater than alpha, then we are going to accept, or we're going to fail to reject HO, which is to accept HO. So that's what we say here. Make a decision to reject or fail to reject the null hypothesis. Now, if reject HO, if p-value is less than or equal to alpha. Otherwise, fail to reject HO, which means, again, the p-value is greater than alpha. Then we interpret the decision in the context of the original claim. So let's see an example here. Here we say in an advertisement, a pizza shop claims that its mean delivery time is less than 30 minutes. A random selection of 36 delivery times has a sample mean of 28.5 minutes and also a standard deviation of 3.5. Now our question is that, is there enough evidence? Is there enough evidence to support the claim? The claim here said, the companies or the pizza shop said their mean delivery time is less than 30 minutes. So that's the claim. So this will be our HA. So we can see our HA is less than 30 minutes. So if the claim is less than 30 minutes, the HA, then HO should be either greater or equal to 30 minutes. The level of significance is given to us to be 0.01. We already know the sample mean. We also know the sample size, so we can find the test statistics. So it will be sample mean minus the population mean. Population mean will be the 30 over the population standard deviation is given, square root of the sample size is 36 was given. So we have 28.5 minus 30 divided by 3.5, which is the population standard deviation, and divided by square root of the sample size, which is 36. So when we do the arithmetic, our Z value will be negative 2.57. So since it's to the left of 0, we look at our standard normal table. Negative 2.57 will give us 0.0051. Now, since 0.0051 is less than the alpha, or the level of significance, which is 0.01, we are going to again reject HO. So we say since 0.0051 is less than 0.01, reject HO. So here we say at 1%, the alpha is 1%. Level of significance, you have sufficient evidence to conclude the mean delivery time is less than 30 minutes. So let's try another question here. This is also hypothesis testing using the p-value. Here they say you think that the average franchise investment information shown in the graph is incorrect. The average is 143,260. It's incorrect. So you randomly select 30 franchises and determine the necessary investment for each. The sample mean investment is 135,000 with a standard deviation of 30,000. Now, our question is that is there enough evidence to support your claim at alpha equal to 0.05? Use a p-value. Now, first we have to state our HO and HA. Remember, the question here said the information in this graph is incorrect. So this is our population mean. The sample mean also is given. We also know the population standard deviation. We know the level of significance, the alpha. And also a sample size was given to be 30. So here, since the sample size is over 30, we can do our Z test. So we state our HO. Remember, they say 143,260 in the graph is incorrect. So that will be our HO. Our HA is that it's not that value. The level of significance is given to us to be 0.05. We can find the test statistics because everything is given. We know the sample mean 135,000. The population mean is what is here, 143,260, divided by the standard deviation, which is given to us to be 30,000, divided by the sample size, which is 30. So the formula is square root of 30. Now, when we do arithmetic operation here, finish, we will get negative 1.51. Now we need to look for the p-value. So negative 1.51 give me 0.0655. But we are doing two tails, so I multiply by 2. And I get 0.1310. Now, since the p-value is greater than alpha, which is 0.05, we're going to fail to reject HO, or we can say we accept HO. So at 5% level of significance, there's not sufficient evidence to conclude the mean franchise investment is different from 143,260 because we failed to reject HO. So 143,260 can be correct. So next we move to the rejection regions and critical values. And here we say the range of values for which the null hypothesis is not probable. This is the rejection region. And the rejection region is normally divided by a critical value. So a critical value is the line between the rejection region and non-rejection region. So we said if a test statistics falls in this region, it's a rejection region. So the null hypothesis is going to be rejected. And the critical value, ZO, that's the line or the value that separates the rejection region from non-rejection region. So if we want rejection region, it's very important to know the critical value. So this is the step to find the critical value in a normal distribution. First, we specify the level of significance. Then we decide whether the test is left, right, or two-tail. Then if it's a left tail, then we find a z-score that corresponds to an area of alpha. Now, if you're right tail, when you get a z-score, you have to subtract it from 1. I mean, when you get a z-score and you get a p-value, you subtract. When we get a z-score, we go to the standard normal table to get a p-value. So whatever p-value we get, we subtract from 1. Now, if it's two-tail, find a z-score that corresponding to half alpha. And so it will be 1 minus half alpha. And then we sketch the standard normal distribution, draw the vertical line that separate the rejection or rejection, and normally to be the zero critical values. So let's see an example here. Here they say we should find first the critical value, then rejection region for a two-tail test. Alpha is 0.05. If it's two-tail, then to the left, we should get alpha is 0.025. To the right will be alpha is 0.025 also. Then 0.025 plus 0.025 will give us 0.05. So we have two tail. So you can see we divide alpha by 2, because alpha is 0.05. So the rejection region are to the left of negative 1.6 and to the right of. Now, if I have 0.025, the alpha value, I can find a z. So we get a z value for based on the alpha value. And now, to use the rejection region to conduct hypothesis tests, we need to calculate the standardized test statistics first. So it's in the rejection region, then we reject HO. It's not in rejection region, then we fail to reject HO. So you can see if it's somewhere here, fail to reject HO. In the rejection region, then we reject HO. Same to apply to the right tail. Rejection region will be the blue area. Fail to reject HO will be the brown area. Then we have two-way, both left and right tail will be the rejection region. And the brown area will be our fail to reject HO region. So using rejection regions for a z-test for population mean, these are the steps. First thing we need to do again is state the claim mathematically and verbally. And that means to identify the null and also the alternative hypothesis. Then secondly, we have to specify our level of significance, which is to identify the alpha level. Then we sketch our sampling distribution. Then we use the standard normal table, because we are doing the z-score to find the critical values. We start with the p-value. Then if we know the critical value, we can determine the rejection region, because the critical value normally divide both the rejection and rejection region. It's a line. After that, we find the standardized test statistics. In this case, we are using the z-score. Then after that, based on the z table and the z value, we get the p. Then we are going to make our decision, either to reject or fail to reject the null hypothesis. So here we say if z is in the rejection region, then we reject HO. If it's not in the rejection region, then we accept HO. So we need to interpret the decision in the context of the original claim. So now we saw the steps. Let's try the example here. Here we say employees in a large accounting firm claim that the mean salary of a firm's accountant is less than that of its competitors. So that's a claim, and which is 45,000. So that means HA is less than 45,000. If that's the case, then HO will be greater than or equal to 45,000. So a random sample of 30. So this is good. We can use, since the size is 30, we can use the z-test. Of a firm's accountant, they also gave us the mean salary of the sample of 30 is 43,500 with standard deviation of 5,200 at alpha equal to 0.05. So we should test our employee's claim. Our employee's claim said it's less than 45,000. So we state the HO and HA. 45,000 greater than or equal, HA is less. Alpha is given to be 0.05. So if that is the case, we are to the left. So our Z value will be negative 1.645 according to the table or the value we calculate. Then after that, we find the test statistics. The actual test statistics was negative 1.58. Remember, negative 1.645 is the critical value that will help us to get the rejection region. And it's based on the alpha value because you have a 1 minus alpha over 2 concept. So here now we find the test statistics, we get negative 1.58. So we are going to fail to reject HO. The reason why, because when we get the value of P from negative 1.58, is greater than 0.05, so we fail to reject. So here we say at the 5% level of significance, there is not sufficient evidence to support the employee's claim that the mean salary is less than 45,000. Let's try another example. So here the US Department of Agriculture reports that the mean cost of raising a child from birth to age 2 in a rural area is 10,460. So this will be our population mean. Now you believe this value is incorrect. So you select a random sample of 900. So our sample size is 900 and find the mean cost. The mean cost of a sample is 10,345 with a standard deviation of 1540. Then alpha is 0.05. Is there enough evidence to conclude that the mean cost is different from 10,460? Yeah, so here we can do the z-test. Why? Because the sample size is greater than or equal to 30. And secondly, is the population mean is given. So let's go through the step. First, we're going to, again, state our HO and HA. Remember, in the graph, 10,460. So we can see, and the question says it's incorrect. And the rural area is 10,460. So we believe that value is incorrect. So we have 10,460. Then HA will be not 10,460. Alpha is given. So we find the rejection region. So alpha is 0.05. Then the Z corresponding to that will be negative 1.96. Then positive 1.96. Then we can do our test statistics, which is the sample mean minus population over population standard deviation over square root of the sample size, which is 10,345 minus 10,460 divided by 1540 divided by square root of 900. So that gave me negative 2.24. So we decided to reject HO. The reason why, because the p-value we get, again, is less than the alpha value. So at 5% level of significance, you have enough evidence to conclude that the mean cost of raising a child from birth to age 2 in a rural area is significantly different from 10,460. Again, when you look at your standard normal table, negative 2.24 will give you the p-value, and that p-value will be less than 0.05. So this will be our conclusion of this lecture, which is hypothesis testing with a large sample. And a large sample means, again, the sample size is equal to or greater than 30. So the process, again, is that always we state our problem, then we can be able to identify our HO and HA. HO is the null hypothesis, HA is the alternative hypothesis. After that, we do our test statistics. Here we are using the z-test. Why? Because the mean of the population is given. We also know the standard deviation of the population. And most important, the sample size is greater than or equal to 30. So when we get the z-value, we go to the table, the standard normal table. Now, if our test is a left tail test, whatever value we get for P in the table, we finish. If it's a right tail, that means it's to the right region. The P values in the table start from the left to the value of the Z. So we have to subtract our answer from 1 if it's a right tail to get the P value. Now, if it's a two tail, whatever P we get based on the Z value, if the Z is negative value, we are doing left tail. If Z is positive value, we're doing right tail. So the answer we get for the P, we multiply by 2. Then we use it to test our alpha, whether we should accept or reject. So again, this will be the conclusion of our lectures. And again, wish to see you in our next lectures. Take care. Thank you.